Let's look into how can we construct any angle. See, we are not going to use your protractor. We are going to use only compass and construct things. So how is this possible and what is the logic behind it? First is let's recall about angles, especially the parts and the logic of how we have a protractor made. So for that we need to recall about first thing is initial arm. So that's the line from where we measure the angle, and if we swipe in this manner, the amount of swipe is your angle. So this is your vertex, the point wherein the initial and the final arm meets. So this ray is your initial arm, and this ray is your final arm. This is generally how we call it, right? And now, so the basic funda of a protractor is that this entire set of things, rotation, is divided into 360 parts. So if I want, say half, not half, okay, half. If I want half a rotation, one complete rotation is an arm going entire thing and coming back. Half rotation is over here. So if I want to do it with a protractor, I just have to look at 180 and draw a straight line, basically, kind of. Not, yeah, if I draw a straight line, it's 180. If I want 90 degree, then from the vertex, I just have to do this. As simple as that. 270 will be over here. So that's how a protractor is made use of. But we are not talking about protractor, we are talking about how to do it with the compass. Okay, so let's come back to the initial arm again, A and I. So what will I do is with our compass, I will draw an arc. So that's the whole idea of a compass, right? We can draw circles. So now this arm intersects the initial arm at say point P, and we have drawn a semicircle with a radius of AP. With the same length, say this is 3 centimeter, with the same length from point P, I'll cut an arc. With surety, if you have done a good job, this by default will be at 60 degree. The point wherein these two arcs meet will be at 60 degree. How is this possible? What is the logic behind it? The logic is simple. A, say this is Q, AQ is again a radius, and PQ is the length of a radius, so that is 3 centimeter again. So all these lengths are equal. So in this case I have drawn 3 centimeter, so it will be 3 centimeter. It can be 10 centimeter also, not an issue. 100 also, 1 kilometer also, not an issue. But we know for sure that this is 60 degree because this is an equilateral angle. So can we find 120 degree? Yes. So with 60 or point Q as the base, if I cut one more arc with the same radius, again we will get an equilateral triangle. So all these lengths will be the same and we get an equilateral triangle. And we cut once more from 120 degree, I get 80 degree, and again we get an equilateral triangle. So this is 60 and one more 60. So we have 60, we have 61, we have 60. If we want 120 degree, I'll stop at the second 60. 180 degree at the third 60. So this entire thing gives me a one complete rotation. Not one complete, half a rotation. Now, if I want say 90 degree, well, we can't do 90 degree as per this logic. We can't do 90 degree. I mean, we can't anyhow you do, we can't get 90 degree, right? But I want 90 degree. I want other angles. The whole idea is to construct any angle. So that's the heading, right? How will we do this? It is with the help of angular bisectors. So how do angular bisector work and what are they? They're able to cut angles into two equal half. So with this logic, right? So we are able to how do you put it? Cut an angle. So say I want 150°. I'll talk about 90°. So let's talk about 150°. So if I want to bisect it, okay, actually let me come back to angular bisector. So angular bisector, the funda is it takes an average between initial and final. Okay, let me write it neater. Average between initial and final angle. So I have an example for 150, so I'll go with 150. I want to construct 150. On the same logic, you can construct 90 also, 45 also, 60 also, not 60, 30 also. So what is the logic? See, quite simple. If I take the average between 180 and 120, so this is 180 plus 120, this entire thing divided by 2. So the average is 150°. So that's how you can construct 150°. So if I want to construct 90°, how to do this? So take an average between say 120°, then 60°. So this will give me 120 plus 60 by 2, and this is clearly 90°. 180 by 2 is 90°. This is how you can construct any angle. So with this logic, I can construct say 45 also. So I already know 90°. So if I take the average between, so constructing 45 is simple. Take the average between 90 and 0. Okay, you draw first 90 and take the average between 0 and 90. That is, you bisect them. Okay, so when I take average, with regarding to construction, we need to angular bisect them. So this will give you 45°. So all this average is nothing but they are aka your angular bisectors, also known as your angular bisectors. So how to bisect an angle, that basics I have done. So see that and come back to this logic. Okay, so these are few things that you need to remember. Not a lot of logic, but there are few logic. If you understand 2 to 3 logic, then the construction part becomes simpler. So next logic is about a triangle, particular triangle. So understand that, and all these 3 logic put together will give you guys the basics for your construction. Okay, so how is that we are going to do this practically? First we have an initial arm, then we draw an arc. From the point of intersection of the line and the arc, you cut one arc, one more arc, and one more arc. Depending on what you guys want, we'll do so. Since we want 120 and 180, so we'll cut all of this and we'll reach 120 and 180 and take an angular bisector between 120 and 180 and then join the vertex and this point, and that will give us 150°. Okay, so this is how you will get 150°. So this we will see practically now. So practically we'll see how is that we get to do it on a sheet of paper. So as you can see, we have an initial arm, so first thing is we are drawing an arc. So So with the point of intersection of the line and the arc, draw one more arc, and one more arc. That those things will give us 60. That point will give us 60, and that point will give us 120. And one more cut, and that will give us 180. Again, the logic is quite simple. All those lengths are equal, and we are getting an equilateral triangle. And now bisecting 120 and 180 is our job. So let's bisect 120 and 180. So please watch how to draw an angular bisector and the logic behind it. So that will make sense. Right, that's your 180. Again, marking all this is a good habit so that you guys are sure of where your compass is. So how to draw a line, even that is a trick. So first is mark your critical points. Then keep your pencil first at that point, and then keep the scale like this. And then draw a small line to be sure, since I was confident, so I drew a straight line. So this is how you should draw lines. Okay, so as you can see, you can clearly see that we have 150 degree. I hope you guys enjoyed the logic. Again, I like teaching logic because logic only makes sense. Everything else is just, examples. Example of that logic. You're learning logic. You have to learn logic, nothing else. Everything else is secondary. So this is how you can construct any angle. The basic thing is you have to take the average of initial and final angles. So this are your different same idea but different language. This is about construction, angular bisector, and if you go with your algebra and arithmetic, it's an average, right? So please copy all of this. Then you have to see to that you'll draw 150, 90 degree, 45 degree. All of this you guys have to draw. Please enroll to our program at chalkpieceacademy.com, wherein we'll be teaching you a lot more tricks for faster simplification and calculation, DIY projects. We'll code with Python. We'll work with Arduino Uno. There are a lot more magic tricks and the physics behind it. They are printable materials which will help you recap and understand things better. We'll have live revision and doubt session 2 months before your term exams. It's very cost effective. There would be no ads or any kind of distractions, and we have a dedicated app to help you guys with this.